let's start with refining here the counter. We implemented the counter using these T flip-flops, but let's actually use and see how it works under memory, our counter module. And I'm going to get another hexadecimal display. I'm going to create another label here, count number 2 with 4 bits, and I'm going to connect that to my 7 segment display or hexa display. And now this counter, what we're going to do is the output of it, current value, is going to have that label. So 4 bits facing west, let's put it here. I need to change the counter to 4 bits too. Alright, and now I'm going to give here the clock, which is our clock over here, but I'm going to use a button to see how it works first and see what happens. So if I press clock, here you go, starts counting. So pretty much I'm doing already all this part of the counter plus the clock. Just by doing this, gets to F and goes back to 0. So let's see if we can incorporate this detection circuit over here. So operates exactly the same way. I have here, this is my clear. So if I go in, I put a button here really quick, we can see how it works. So I'm counting, and if I press here, it clears. So counting and clears. So it's doing this part of the clear. All right. Let's then, so I need to affect exactly the same thing. So pretty much I can use the same gate, AND gate, and have it with the counter. I need to have a splitter. Splitter is going to have 4 bits facing east, it's fine. So I'm going to put it here, and the value comes from here to the input and here. And now I'm going to have, I need to have the value 10 over here. So let me grab the NOT gate and have the NOT gate connected to this one, and the NOT gate connected to my second one. All right, let's connect these. All right, great. And last one, this one. And the output, as we know, is going to reset my clock. Great. I'm going to put here, so I know just a label, and just a label indicating that at 10 this one is going to reset. And let's see if it works. So if I press 7, 8, 9 and it resets. Great. So if I substitute this by a clock, and this clock is working at 2 Hz. So if I enable, I have my counter working here and resetting at 0. And if I enable this counter over here, you will see that they work exactly the same way, just a more compact version of what you have over here. So the lab for this Wednesday, it's a Logisim project, and you're going to be doing a 7-segment display clock. So we want to have this behavior, a bunch of 7-segment displays or hexa displays for Logisim, and we want to implement the clock. You start with the clock, and then the challenge, if you don't find a challenge, you can do something, you can augment that clock, and you can do something to adjust the clock time, or implement a stopwatch, or a timer with an alarm, or an alarm clock. So these are good improvements that you can do once you have your clock up and running. It's not mandatory, again, this is just for you guys to practice, and then I'll post the solutions on Thursday. I'm also providing a template, so you can start from here. You already have here your hexadecimal displays over here with the respective labels, and the circuit of the first one counting seconds up to 9, the first digit of the seconds 8, 9, and resets. So once you are testing this, if you want to make it faster, just go here and just make it faster so you can see the circuit being simulated. So probably that's too fast, but something like this, and then hopefully we'll see all the other ones incrementing properly. Have fun.